Hi, good day everyone. I am Aaron Clarismon from BSN 1H. So today we will discuss about lipids. Lipids are a broad group of naturally occurring molecules which includes fats, waxes, sterols, fat-soluble vitamins, monoglycerides, diglycerides, phospholipids, and others. The functions of lipids include storing energy, signaling, and acting as the structural components of cell membrane. Lipids are a group of hydrophobic molecules that play an important role in living organisms, while the primary function of lipids is long-term energy. Storage lipids are also used for projection, insulation, and lubrication. They also act as precursor for some hormones and key components of cell membrane. There are four basic groups of lipids. These are triglycerides, phospholipids, steroids, and wax. Although this group difference mainly respect the all one characteristic in common. They are all insoluble in water. You may have noticed that lipids and water do not mix. For example, notice the yellow-colored oil in the beaker of water shown here. Even if we stirred this for several times or even several hours, the oil would still separate out from the water. This is because lipids are hydrophobic. From Latin, the prefix hydro means water and phobic means fear of. So when you hear the lipids are hydrophobic, this basically means that water and lipids do not mix. Let's take a look at the category of lipid known as triglycerides. Triglycerides include the fats and oils. Fats, such as lard and butter, are solid at room temperature and are used by animals for insulation, protection, and long-term energy storage. Oils such as corn oil and olive oil are liquid at room temperature and are used by plants for long-term energy storage. Describe triglycerides in a molecular level. At the molecular level, triglycerides contain two types of subunit molecules, glycerol and fatty. Let's take a quick look at fatty acid. A fatty acid has three main parts, a chain of carbon and hydrogen atoms called the hydrocarbon chain, a methyl group at one end, and an acid group at the other end. Fatty acids can be either saturated or unsaturated. A fatty acid that has only single carbon-to-carbon bonds is known as a saturated fatty acid. This is because the carbon chain is saturated with all the hydrogen atoms it can hold. Unsaturated fatty acids have several double bonds. Double bonds result in kinks in the fatty acid chain, which affects the melting point of the fat. Animals' fat saturated fatty acids and are solid at room temperature, while vegetable oils have one or many double bonds and are liquid at room temperature. A trans fat is an example of an unsaturated fatty acid where the hydrogen atoms are on opposite sides of the double bond. Trans fats are usually formed during the production of processed foods and are also common in partially hydrogenated oils. In order to increase shelf life and melting point of the fat, excess hydrogen atoms are introduced to an unsaturated oil. This causes the formation of trans fat bonds in the fatty acid chain. Unfortunately, the consumption of trans fat has been associated with the cardiovascular disease and its use has fallen from favor. Now, let's zoom back out and look at how the triglycerides are knitted together. Remember, a fatty acid is only a small part of a triglyceride. To become a triglyceride, three separate fatty acids must bond with a glycerol molecule through the process of dehydration synthesis. Let's move on to the categories of lipids, which is phospholipids. Phospholipids are like triglycerides in that they contain glycerol and two fatty acids. What's different is that phosphate group rather than a third fatty is attached to the third carbon of glycerol. Phospholipids are extremely important, mainly because of their unique properties regarding water. The phosphate head of the molecule is hydrophilic or water-loving. This means that it mixes well with the water. The fatty acids, tails, however, are hydrophobic or water-eating and do not mix well with water. Because of these unique properties, phospholipids tend to arrange themselves that only the hydrophobic heads interact with a watery environment and the hydrophobic tails crowd inward away. Steroids are the next category of lipid. Steroids are composed of four fused ring or carbon to which different functional groups are attached. One well-known steroid molecule is cholesterol. Cholesterol serves as precursor for the synthesis of other steroids such as testosterone, estrogen, vitamin D, and cortisol. Cholesterol is present in plasma membrane where it stabilizes the membrane. The hormones testosterone and estrogen have small differences in their functional groups but large differences on their effects on an organism. Polar and lethal water they found in protective coatings on leaves and on outer surface of animals. Waxes is produced airs of some animals to protect the eardrum in aditio. Bees construct honeycombs from wax. Now that we've covered all four categories of lipids, let's do a quick recap. The four categories of lipids are triglyceride, phospholipid, steroid, and wax.